Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, 7th SEM from the Department of Computer Science and Artificial Intelligence. Today I am going to present about the topic addressing the strategies in IoT, which comes under the subject Internet of Things. In this presentation, I am going to present about the topics Introduction to the Internet of Things, key addressing challenges we face in the Internet of Things, IPv4 and IPv6 in IoT, domain name system DNS and IoT, addressing strategies in IoT, name-based addressing and ID, that is localator split, and addressing low power IoT networks. Introduction to IoT addressing. Addressing in IoT refers to the process of assigning a unique identifiers. Those are the IP addresses of each device within a network. These identifiers, those that IP addresses, they allow devices to communicate with each other and with the central system, that is the cloud platforms, efficiently. So what are the roles of addressing? Roles of addressing is to ensure the seamless data transmission between billions of interconnected devices, facilitates the device management, tracking and data routing. The main and the important and the current modern example of Internet of Things is smart house system. Smart house system runs on the principle of Internet of Things. Why is addressing important? Addressing is important for unique identification. Every IoT device needs a unique address, unique IP address to ensure the data is routed to the correct destination. And addressing is important for the efficient communication. Addressing mechanism prevents communication overlap or errors, ensuring reliable device to device connection and device to cloud interaction. And it is also important for security, that is the proper addressing helps identifying devices, enhancing security protocols by ensuring only authenticated devices can communicate within the network. And for scalability, with the rapid growth of IoT, scalable addressing solutions such as IPv6 are crucial to support billions of devices globally. Here you can observe the difference between IPv4 Internet Protocol version 4 and Internet Protocol version 6. In Internet Protocol version 4, they use a 32-bit addressing system providing approximately 4.3 billion unique addresses. And the limitations are addresses exhaustion, that is, with the rapid expansion of the internet, the available IPv4 addresses are nearly exhausted, which poses a challenge for a growth IoT ecosystem. Smaller networks suitable for local or smaller scale IoT deployments but become problematic when scaling up global IoT networks. Moving on to the Internet Protocol version 6, the overview of this is that it utilizes a 128-bit addressing system. It provides 140 undecillion unique addresses, making it ideal for IoT's large-scale needs. There are key benefits of this IoT system in IPv6 is that a vast address space easily supports the exponential growth of connected IoT device, ensuring each device can have a unique address, simplified header format, better support for mobility. These are the key benefits for IoT in Internet Protocol version 6. Here are the main and the key points of IPv4 and version 6. The next topic is domain name system, DNS and IoT. The domain name system, it is a system that translates human readable names into the IP address. So the domain name system, the main agenda is to translate the human readable names into the IP addresses that device used for communication. Device can only read the IP addresses. So the domain name system, it usually translates the human readable names into the IP addresses. Here you can see the example of human readable names, example device1.example.com, and if the IP address, here is the example for IP address 192.168.1.10. Here this you could have observed in the Wi-Fi used in a large scale. So these are the IP addresses most of the devices contains of. So importance in IoT is that the device management, that is DNS, help manage large scale IoT networks by assigning the readable names to each device, making it easier for the users and the systems to identify, locate and interact with the devices. The next importance is simplifies the communication. DNS allow IoT device to connect to cloud service, other device and the data servers by resolving the names into the addresses automatically. Next comes the scalability. As Internet of Things network grow in size, DNS is a crucial for organized management of hundreds and thousands of devices, ensuring the smooth operation and interaction. So challenges with the DNS in IoT is that the dynamic addressing, that is which is not constant. Many IoT devices they use the dynamic IP addresses that change frequently. DNS needs to adapt to this dynamic environment, which can complicate the device tracking and management. Next, moving on to the security vulnerabilities. DNS spoofing and poisoning, which means attackers can corrupt the DNS and redirect IoT device to the malicious addresses, leading to the potential data breaches, unauthorized access, and the system failures. And privacy concerns and need for secure DNS. These are the challenges. These are the two challenges with DNS in we observe in IoT. So here are some addressing strategies in IoT. First comes the static addressing, that is assign the fixed IP address, that is not dynamic, it is very fixed and works well in a small or local network where devices do not move often and need to communicate reliably with a predefined address. For example, smart home and small scale industrial settings. Advantage is that it simplifies network management for small environments, and main disadvantage is not scalable for large IoT systems. Next, moving on to the dynamic addressing, using uses dynamic host configuration protocol to assign IP address automatically as device connect to the network. So here use cases are suitable for large or more dynamic networks where device join or leave frequently. For example, smart buildings and campuses. So fixed addressing or constant addressing is for smart house and dynamic addressing is for the smart buildings or campuses. Advantages are automates IP assignment, reducing the manual intervention. The main disadvantage is more complex to track devices as IP addresses may change over time. Next, hierarchical addressing, that is organize the IoT devices in a tree-like structure with addresses reflecting their position within a hierarchy. For example, region, device. So the use cases of this hierarchical addressing, it is highly scalable, especially useful for large networks like smart cities or industrial IoT system where devices are grouped by location or functions. We discussed about the fixed addressing, dynamic addressing, and this hierarchical addressing. Fixed or fixed addressing is for the smart house system, and dynamic addressing is for a large scale, that is smart building or campuses, and hierarchical addressing is for building a smart city. For advantages are the scales well or for vast networks, and main disadvantage is more complex to design and implement. Moving on to the last one, that is geographical addressing. It assigns addresses based on the physical location of device, which can be derived from GPS coordinates or geographic zones. Commonly used in smart city applications, agriculture or logistic where devices locations are crucial. The main advantage is make it easy to locate and manage device geographically, and the main disadvantage it may need frequent updating in device move. So moving on to the next topic, that is name-based addressing and ID locator split. Name-based addressing is the IoT device are identified by human readable names rather than numerical IP addresses. This how it works means it instead of routing data based on IP address, the network forwards data based on content or device name. It is suitable for emerging network models, and the main advantages are efficient content delivery, enhanced scalability, and caching benefits. Future of the IoT addressing scalability and efficiency, mobility and security, and emerging of technologies. And the final thoughts about this presentation is that addressing in IoT is not one size fit all approaches. The selection of an addressing strategy depends on the network scale, mobility needs, security requirements, and the other types of IoT devices involved. Thank you. Please do like the video.